Hello and good day. My name is Dirk Dennis from MUTOH Europe, and in this training video I will demonstrate how you can make your own profiles for our Vertelith software. During this presentation I will be using our Vertelith version 6.1, Profiler version 2.6, and I would like to add a 2.7 is coming out very soon, a matter of weeks, which will have support for the i1 Pro 3 version. I will be profiling on our XPRICHIT 1682 SR Pro firmware 102 with our fantastic MS51 super glossy and rich colored ink. And to make the profile, I will be using the X-Rite i1 Pro 2. So of course, before you start to profile, your machine should be 100% okay. Here I'm giving some tips. So the first is for technicians, not going too deep in that. Every technician has been trained and know what these are and how he should adjust them. But this is of course crucial to have good printout. As a user, once your technician has done his job, you should of course do maintenance. Nozzle check will prove that your maintenance was okay. You should do your paper feed adjustment, the step, and on the current firmware, the micro adjust is the best option. We are expecting a firmware 103 where we will have a new automatic adjustment that might be at the same accuracy like the manual micro adjust. For the moment, my advice is to just use the micro adjust. The adjustment print, which is the bidirectional setting, the automatic ones here work very nice, but in case the auto adjustment fails, which can, for example, happen if you have media which is sensitive to cockling, you should switch to the custom ones and perform rough and fine adjustment. What you are doing is stored per head height. So if you adjust your printer while the machine is in head height low 1, the adjustment does not automatically count for head height low 2. You should do it again for head height low 2, of course. Check our print mode documents, which will come on the next slide, to see which pattern you need. And this is, of course, depending on the machine. The software itself, again, check the print mode documents because it's quite crucial that you follow our guides to have top-level profiles. Avoid conflicting settings, like for example, do not set your paper feed adjustment on the printer and at the same time use a different value for the step adjust from the profile. We don't advise this. My advice is always to do all the adjustments on the printer itself. There are 15 users, that should be more than sufficient, and each user per media type can have bidirectional and step adjustments. In case you are in doubt, or this might also perhaps apply to third-party software, we have a header dump function. When you switch on the header dump, after each print you send to the printer, the commands will be printed. Also the ink usage will be printed, so you can be 100% sure which dot size, for example, you are using. And of course you can take a picture of this with your smartphone and communicate this to MUTOH local support in case of any issues. To know which print modes I should use, I will take the document which gives information about the printer I am using right now. So this is our double head machine, and I will be making a quality profile in the 13 square meter per hour. Notice that we have a advice of 2 different dot families. Highest quality will of course be achieved on small dot, but we did notice that certain vinyls in certain environments have issues with static electricity, which might be causing ink mist, and we noticed that a simple solution is to use a profile in large dot family. Quality is of course better in small dot family, but a large is very acceptable, gives very good quality. The only thing is, if you make your 2 profiles, you will notice that there is of course a large difference in your primary ink limitation. So for now, I'll go for the 13 square meter per hour, and I'll make a robust profile in case of static electricity, a robust profile which is using the large dot. This information here helps me to learn about the adjustments. So here you see the patterns in the printer for the bidirectional adjustment. And I'm using large drop in the high carriage speed. I should only adjust pattern D. Of course I can adjust all the other ones as well, but pattern D will be sufficient if I don't want to lose too much time for that. So, like the document says before profiling, I'm here in user type 5, I will do my adjustments. So starting with the adjust print, I'm not using the old first generation dot master, I just skip this. Automatic, and since I'm using large dot family and high carriage speed, I know I just need pattern D. Maybe you notice that when the printer makes the pattern, you always get confirmation in the side margin. It will tell you it's pattern D using large dot and also using the carriage speed. We have a successful bidirectional, so I will now go back and adjust in type 5 my paper feed. Again, not using automatic, not using the initial one. I will only use the microprint. Keep in mind that you can adjust your step while working to sheet, but if you after creation of the profile, if you are going to work roll to roll, you should readjust the step once the material is attached to the roll. So when I check, my step was actually already adjusted. My step was already very good, so no need to change the number, otherwise you could fine-tune, have a different percentage. Just enter, you can always repeat this one, always do it again. My step and my bidirectional are adjusted, my machine is up and running, we can start the profile. When I have my Vertelith software, I have my printers which are installed, and in here you should of course take care of network settings. If you start the Vertelith profiler, he will automatically link himself to Vertelith. There is nothing you can set here, and he will show you the printers which are installed. So now I will create a new profile. We'll click on next. The basic information, of course, which ink setup I'm using and which resolution I'm using. My high quality profile is in 1200 by 1200 dpi. The group in which my profile will arrive will be the MS51 group. You can create new groups as much as you like. It's even possible to afterwards change media from group to group. So this is my video demo profile. Next. As soon as I click next, the profile is, the SSP file is created, and we can start by adding information. So resolution has been chosen. Keep in mind that when you make a profile, resolution, color mode, and dot size are crucial decisions you make. Once they are made, you can't change them anymore. If you do want to change them, all you can do is make a new profile. Select the options. So like I said, I will go for a more robust profile, which is using the large dot family. On our new Pro machines, we give the advice to use variable dot as much as possible. The carriage speeds I'll set to high. And now a small, or when I finished, I will give you a small cowboy trick. The effect for my 13 square meter per hour was the fine weaving. There is not a great difference between the 1, 2, 3, 4, 5. It's just a matter of having the X weaving. Those 1, 2, 3, 4, 5s are starting points and are more for engineering purposes than what the customer needs. My shuttle width, to move faster, I'll just go on data width. If I would take a safe profile, I always select media width. right now just want to have some speed. Data width, side margin by default on 5. My vacuum I'll set to high. Temperature of my preheater 37. Very important for our MS51 ink, we do not advise that you set your platen heater above 35 degrees. The ink is very fast drying and this is more than sufficient. 45 for the afterheater. And this should be it. So, like I said, adjustments like media feed, I will not send this from my profile. It can conflict with what I set in my printer. Even the old dot master, I have done my automatic bidirectional, so I do not need the thickness of the old dot master. This should be quite sufficient. If I just print, he will use the active user, which is now 5, or I can also set user 5 fixed in my profile. This way, each time I use the profile, user 5 is invoked on the machine with the accompanying adjustments. But right now, I will leave it like this. If I pass the profile to another user, he can still make his own decision in that. I was gonna say a small cowboy trick about this one. Of course, we all want to print bidirectional. It gives us more speed. But the bidirectional can be an issue, or let's say a risk of having more mistakes in case your dot master is malfunctioning, wrong calibrated, whatever. This will show as grain and will result in wrong color. Judging the step is quite easy. Measure the length. Judging the bidirectional you can only do by seeing the quality. What I do many times, and especially like on dye sublimation, I make my profile in Unidir, do all the measurements in Unidir, because if you do so, there is absolutely no risk of having a wrong dot master, wrong bidirectional, or whatever. You should just keep in mind that you must select your ink limitations a bit safely, not too high, because you will speed up the profile by going bidirectional. So, switching to Unidir, when I'm finished, I will switch it back to bidirectional. This is a small cowboy trick, which I use many times. Set OK. Next, you get one chance to set your media width, and this is quite important because depending on the media width, the machine will create different sizes of test charts, the software I mean. So my media has been set in my software. For UV you can enable white underlay. For dye sub you can of course flip the charts because they should be transferred before they are measured. Next, this is my very first step where I will print a chart. By default he's showing me a 50 to 100% chart which I will print. But in my case I already know by heart that using high quality 1200 by 1200 with large dot is putting down lots of ink. So I will be forced to go down very deep in my limitations to get a good result. And it might be so that this chart, starting from 50%, is already way too high. But I'll just demonstrate it anyway to show. So, as I expected, my combination of large dots and 1200 by 1200 is a lot of ink, and even the 50% is not drying fast enough. Simple solution, we will switch to the smaller chart, which is printing the lower percentages. In most of the profiles, this chart is doing just fine, but on the combination I have now, there is so much ink that I simply cannot see my correct starting point. Small word of explanation, what is this? Many of you who do profiling will know the normal CMYK wedges. But if I would use this to choose my CMYK, this is like the 50% here, is a single color of ink, and that's dry. To judge your single colors, we have learned by experience that it's more interesting to see what the double color will do. So if I make red with 50% magenta and 50% yellow, this is the red which I'm getting. And it's crucial that on the first selection of ink limitation, that we make sure our profile will be able to do a very nice double color. Here the double colors are already an issue, so they weren't drying fast enough, and might be difficult to see on camera. I have a sort of bleed border around all of my squares here. So we'll switch back to the other chart. Going back to the profiler, and now I will use the small chart from 5 to 50%, and again print dot chart. So when I check this chart, I will give it like 30 seconds to dry a little bit. I notice right away that my starting point has changed, is now at 5%, which is of course perfectly dry. The idea of the chart is that you go diagonally. So certain inks are not in balance. The chart offers you the possibility, like our very old Eco V3A ink, the cyan was much stronger than the magenta, so to make blue I would go deeper in cyan than I would in magenta. But the MS51 is in very nice balance, so I'll just check diagonally and see to where exactly I have drying issues. So from here it starts getting sticky. This is a bit of experience. There is no golden rule to set your limitation. It is what the machine can do in that amount of time, so you want to have as much color as possible, but at the same time you want to make sure it still dries. It would appear that the 40% still has this bleed border, and I should keep in mind that I will also switch to bidirectional. So I will be safe and select the 35. This seems to be the 35 seems to be the ideal one for all my inks. If I check, yes it is. The red is always the most visible one. So my colors I will set on 35, all of them. Now the black is the only one you should judge individually, and what you do is you start by the right point, look to the left, and from the moment you see your black square is perfectly solid, perfectly closed, that's your black limit, and in this case it's the 30. Those are my limits, which I will set in my software. So as I said, for the black I go for 30, and my 3 other colors 35. These are quite low limits, but this is because we're using large dots in combination with a high resolution. Other profiles with lower resolutions, smaller dots, can easily go to 60, 70, 80, even 90%. This is my restriction of the large dot. Now a nifty feature in Vertelith is the variable dot limit. I don't always print this. You print this the first time, but we are quite used to it. It's a very large chart. I'll just go for the small chart to save some time. It's a very large chart. And the idea is to counter banding by setting a limitation on your smaller dot and your medium dot. We are used that 60 and 30 are good percentages. Right now I'm using a lot of ink. In this case I will have to go down a little bit. I'll just print it as demonstration, but usually we skip this. We just go with these numbers to the next step without even looking at this chart. So these two charts help you to counter banding in the print. You can clearly see by the intensity of the color that this one is the small dot and this is the middle dot. The limitation for the large dot we have done in the previous step. Now here I will not see much banding for two reasons. I took the small chart to save me some time. On the large chart the banding is more visible, bigger patches you get. And second reason, I'm in a quality mode. In a quality mode there is lesser banding. But the idea is that you start looking from the bottom and you go up, and the first sign of banding you get in single color, you go back one, and that is your limitation for that specific color. Like I say, we usually don't even print this chart. We are aware that the 30% for small dots here and the 60% for middle dots is approximately what you will need to have a good result. It helps a lot to counter banding. I am now actually working in a mode which is consuming lots of ink. I will go a little bit lower. I will go for 20 and 50. That's also a bit of experience to set my limitations for the best results. So in my case I can easily choose the same setting for all the inks. So 20 and 50. Next. And here starts my profiling, my first patch which should be measured. As you can see, we support some devices. I will come back on this one later. For the moment I can use my i1 Pro in handheld position, but we have the luxury of having the robot here. So just to go faster I will take the robot, the IO2, to make my profile. It's important that you select the right one over here because the size and the look of your patches depends on this. Print linearization. So this is my i1 setup. Normally I should be using it in handheld together with the ruler. So it would look like kind of this. You put your patches in there, you install the i1, you first calibrate of course, but then you measure one by one. This takes some time. It's ideal for a field technician, but for the moment, since I have the luxury of having the robot, we will mount the machine in the robot and use the automatic way. So I place my linearization on the table, switch on the electrostatic mat, and I start profiling. You can see I have some light conditions. We advise to use the M1. This is the D50 light, the default for press work. And it also automatically does double measurements. So when I click on measure linearization, depending on the instrument, I get different instructions. So I have a robot automatic arm. He will ask me to position the first 3 patches. So move the visor to the center of the first patch, as you can see, and press the button when ready. So I'm moving it. Visor is on the first patch. Okay, right here, pressing the button. Once I have done, you can see he's asking to do first patch in the last row, the second one, which is over here. And then he's asking last patch in last row, which is over there. And as soon as I clicked the last one, the arm goes back to calibration position and he will start the measurement. 2 for each line. And as you can see, the software is getting the data in line by line. Measurement finished. So he says click the close, which is the exit button. So that's my first step. Linearization is now successful. We go to next. And here we print the total ink limit. So just one click on the button and we're gone. So what we see here is the mix limitation starting from 150% and ramping up all the way to 400 because we can put 4 colors on top of each other. Now the idea is that for a good profile, our color engine can start up to here, so he can go as low as like 220, maybe exceptional 210%. But if you notice that the 200, that these patches are not drying as they should, it might mean that you went far too high with the single color profiles, and you should actually return to step 1, the single color ink limit. But in this case, I can feel that my 220 is okay, even my 230. I do get, so the whole line is okay. I do get a small bleed border around this square, but I will simply allow that, and I go for 230. Sometimes you can check intercolor bleeding on the final patches, see how the color react when they are next to each other. But in this case, all seems to be quite fine, and I'm reaching 230% of ink, which will be sufficient for a good colorful profile. So the value we just set in here, and we proceed to the next step, which is the ICC chart. Again, very important to choose the correct measurement device and click on print. This is the ICC chart, the final step in the profiling. I will just move it slightly forward, like this. It can enjoy the temperature from the afterheater. I'll give it 5 minutes to dry completely, and then we will measure the charts. You have to measure them one by one for the final result. My chart is printed and is dry. Again, choose the M1 condition. Measure charts and follow the instructions on the window you get. So the I1 starts with a calibration, and then chart by chart he will ask to measure the 3 points to align himself. So here I see set color target page 1 on the device, and then again, just like on the previous patch, move visor to center of first patch in first row and press the button next. So I got my page 1 of 5. And I will measure the 3 corners to align the machine. So again, while the machine is measuring, I get my measurement data in the software line per line, as you can see here. You can see my software is asking for the second page, so set color target page 2 on the measurement device, and again align the 3 corner patches. So here we go, page 2. So that's it. All measurements are finished. Click the close exit button to leave this window. Measurement succeeded. The final step would be the definition of the GCR curve. So by default, this is how the black color is used. When you make grayscale and you would use only the black color, it would look very ugly. The black has a carbon pigmentation which is quite strong, yellowish, I would say. It will create a gray which is far too warm, and it will also create a gray which is very visible grainy. So instead, what is happening, you start to create gray with CMY, and after a while you introduce black and build down the CMY ink. This is called the GCR curve, and perhaps start a little bit later. You don't want to see black dots too soon in your prints, so start at L level of 25. The end level, never change this, leave to 100, and now you can create the profile. A DOS window pops up and starts doing some calculations in the background. It takes about 3 or 4 minutes, and then your profile will be ready. And the profiling is done. Finish. It's advisable to restart the Vertelith to get access to the profile. But the first thing I'm going to do is switch it back to bidirectional. So I start my printer profiler. Could have kept it open. And on this printer, I click Edit Existing Profile. In the list, I select the profile I just made, the video demo profile. Next, select Options. I get my printer dialog, and here I can switch it back to bidirectional. OK, go next, 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 and save it, finish again, and it will now be in bidirectional. So now that we finished the profile, we can start a test run. And yeah, sometimes it's difficult to find correct images to do so. So I will add 2 jobs which I use frequently for profiling test. One would be my color only, no numbers, my rainbow chart. This is a theoretical file, so I edit this. We select the profile that we made, so that's this one, video demo file. I'll check printer options. So indeed all my settings are correct, large dot, bidirectional. I'll just ease a little bit on the printing, make sure I go edge to edge on the media. Temperature is all okay. So in my Vertelith, my layout, do a get size. And I'll increase this one slightly. Let's see how far we get there. That's should be more than sufficient. Center. So this is a theoretical rainbow file. On the side, I will be able to judge if my grayscale is okay. In the middle line, I will see my strongest red, strongest yellow, strongest green, strongest blue, strongest magenta. And especially at the bottom, you should check for contrast. This patch should be the darkest black possible. The other patches should still contain a slight amount of contrast. In the highlights, we can check if the grain is okay in this profile. So that's my test file. Very important, like in the manual, I distribute the manual for default Vertelith settings. I always print perceptual. I know that Vertelith is by default in colorimetric. It's a long explanation. My advice is go perceptual. You do not want to have any color differences between vector and raster. So that's it. Submit for print. That one is ripping. And I will right away select my other file as well. It's difficult to have a photo as a test file because many photos nowadays are pimped. Photographers also want to have the strongest saturated colors, etc., etc. Something with a bit of neutral colors inside is always nice to test. And something with colors that you can relate to, like skin color, for example, hair color, eye color, something which is, you know, a certain standard as far as that is possible. So we'll edit this one. Again, I select my video profile, get size. This one might be a bit on the large side. 90 degrees. Two copies. Oh, a bit bigger, apply the same. That's it. Bit more space maybe. And that's my second test. Again, perceptual. So this is the final result of my test chart, and I must say it's very pleasing. What to look for? So as I said, we're using a large dot profile. The highlights, also the first gray areas, are the ones you check to see if the grain is acceptable. This is of course difficult to see on the video. For me it's okay. Bit grainy. A profile with a small dot would tackle this, but like I said, it's a choice between having a more stable dot output versus very high fine quality. After you check the highlights, check of course the gray balance. So this also depends on the light in your room. A gray day, not bright sunshine, but a day like a bit cloudy gray would be ideal to emulate D50 light to check if the gray is not becoming reddish, warm gray, or if not becoming greenish or bluish. Actually should be quite neutral. And from white to black, so this is my darkest black, pay attention that the line next to it should have some slight variations in color. This is pure black, these are not, these are almost black colors. In the middle line we have our strongest colors, so we have our most yellowish yellow, greenest green, at the end the most reddest red. Check if they are pleasing. Like this is totally depending on the primary ink limitation. The higher you set it, the more color you can achieve, but the more you might be struggling to have a correct dry time. The last one, which is important, which determines the GCR curve, is like the gradient from red to almost black. If your mix ink limit is too low, let's say 200%, it could be that from red to black it suddenly become a little bit grayish and then black again. That means your GCR curve has to perform way too hard to compensate for the low mixed ink limit. Only solution, alas, is to restart the profile. with lower pure limitations before you set your mix limit. Overall, in the chart, you should also check for the gradients, the quality of the gradients. Like, it should not be so that a gradient starts and suddenly gives a bump to a dark color and then followed by a lighter color again. All the gradients should be smooth, so you would like squint your eyes a little bit, look from a distance. All the gradients, all the transitions, left, right, up and down, should be quite smooth, but this is the perfect example of a good and successful profile. So the same goes for the portrait of the lady. One important thing here is the background. So the background is not perfectly neutral gray, but it's grayish. It's a middle gray, and that is very sensitive to banding and printing artifacts. Like, if you get this one okay, you will get every file okay. The girl looks maybe the skin a little bit warm, but that could be. It's possible that she was in a studio where some warm lights were used. But you check, especially highlighting in the skin, see if it's not becoming too grainy. Transition of the shadow is quite okay. Color of the eyes is good. There are no strange bumps of color whatsoever, especially in the transition to shadow here. You should check for strange bumps. Could be caused by wrong choice of limitation. But overall, the color looks like normal skin color. The gray background looks okay. So again, this is a successful profile. A final tip I want to give on managing your profiles. So the profiles of Vertelith are stored in the program data files. So although the program itself is over here in program files, this is the installation folder for the program with the manuals. The profiles and all other files, print files, presets, are stored in program data. So don't forget program data. You must enable the hidden items before you can see that. If I go to program data, MUTOH Vertelith, and I go to profiles, you will notice that all the profiles are nicely ordered per printer model. If you go inside the printer model, they are ordered per ink setup, and then they are grouped according to the groups which you have created. So in the MS51, I get the date today is 19th of July. So this is the profile I just made, although the name is not video demo profile, but the name is stored inside the SSP. If I open this, you see this is the name by which it displays on your screen. You can actually change that name. You can change the name of the SSP, doesn't matter, it doesn't change the name which is shown in Vertelith. Just be aware your profile consists out of this and that. One way of passing it on to someone is copy both files, and if both files are sent to someone and he copies this on the exact same location, so program data, MUTOH Vertelith, profiles, printer, whatever, then he will get automatically access to this profile. That's one way of doing it. For your own convenience, you can also store that, or you can give it a name. So if you are a technician who makes profiles, with this name might be difficult, so I will just go back, and I call this my video profile, like this. I can give the same name to the ICC, but if I do this, the ICC will be lost. Lost, I mean no longer accessible. I should copy that name, open this file, and make sure that at the bottom, right here, I let this SSP point towards that exact file name. They should just be in the same folder. There is no need to add a path over here. So that's one tip I can give you. The other tip to export profiles would be using the profiler. There you can manage profiles, and if you just select the group in which you made the profile here, you can export this. So like this, export profile on my desktop, save, okay. And this is a profile which I can now email to someone and he can install it in Vertelith in the normal way with the profile management. As a technician, I just want to point out that it could be very handy. One moment, to have this entire library with you. It's a matter of copying the whole thing if you install a new PC and all profiles are present. Vertelith will also not delete profiles. If you delete a printer, the profiles stay active. So I exported that one, and now, for example, if I want to import a profile, I can do it. Profile, library, take my printer, click on the download button. In this case, I'm not connected to the internet, but I can import, and it will search for this MPDF file which contains the profile. Now you have seen the workflow with the i1 Pro 2 device, and I would like to add a final note on this training course. With the profiler comes a manual which is quite complete. So the manual, you can easily read through, table of contents, see how step by step you do everything, all nicely explained. What I want to explain is the devices which are supported. So as soon as I create a profile, next, and I pick my color profiling device, I will be quite honest, so for the moment version 2.6 has an issue with the third version of the I/O. The first version also has some accuracy issues. But we have a very nice workaround for that. Like the same workaround, if you have a Barbieri device, you are using an in-between software called the gateway software. And we can actually import from the i1 profiler software, which is for free. If you have a device from X-Rite, you can download the i1 profiler. You don't need to have the professional one. And with the i1 profiler, which is this software, you can always use your measurement device and you can do a measure chart. So you have to define your own chart according to what will be printed by Vertelith, measure it with an i1 Pro or even an i1 3, and then you can export this chart and import it back. If you click on measure linearization, you can actually measure a file. So that's our workaround, and if ever you need it, like if you have an old first generation i1, everything is mentioned here. Step by step, just follow it step by step. So linearization using measuring device, that's what I have done. But there is also a test chart with the i1 profiler. So here they go. They show step by step what to do, how to start the software. And how to define your chart, make the measurements, and once finished, export as a CGAT file. Once you did all that, you will be able to import the file into the MUTOH profiling software. So that's just a workaround I wanted to point out in case your color profiling device is not 100% supported directly by our software. So that will be it for the training. Hope you enjoyed, and I hope your profiles give you the best quality ever. Goodbye.